Welcome to this explanation of ventilatory threshold. And in this lab we're going to do a couple of fun things. This is kind of the culmination of everything. You know how to write an introduction, you know what goes into method section, and which things to put into results, and now we're going to focus in on the discussion while also reconfirming what you already know about the other sections. As far as what goes into a discussion, I think you should start off your initial paragraph with a recap of what the study was doing. So this is an old study of mine that I found, and if you take a look at that first paragraph, basically what we did was we started off saying what we wanted to do. The study was designed to determine, and you can read there, so that's your kind of initial sentence into the lead paragraph. And then we go and we describe the main findings of the study. Your next several paragraphs will focus on trying to explain the results and incorporating literature. And probably the best way to go about doing this is to take it variable by variable and to talk about what you found, and then to pull in other literature and compare and contrast. If it was the same, great, provide that evidence. If it was different, you still provide it and you try to explain where the differences occurred. And I'm not going to go into detail on this, but you can see that I've got 3 paragraphs for the 3 different variables or 3 main findings that we had. And then in your final paragraph, a lot of times what you'll do is you'll include limitations of the study, things that you acknowledge that you could have done better, and that often leads into future studies. So we could have done this better, and in the future we would like to do this. Or if there were things that you noticed throughout the course of completing the study, it doesn't necessarily have to arise from a limitation, but it's nice to say, in the future we'd like to do this. So let's go back to this paper, and you can see in summary, that's the beginning. We do go down and we talk about, kind of wrap it up. I'm not sure any limitations are noted here, but I would like for you to include them in your discussions. And we finish there by saying that future research could focus in on measuring catecholamines and such. And that would be a good thing for you to do, is to include future investigations. So for this laboratory write-up, I would like for you to have 2 main research questions. And one of them is, are there relationships between the methods? And I'm asking you to do this so that you can practice running correlations. And then the other research question is, are there differences between the methods? And I'm asking you to do this so that you can practice doing an ANOVA or doing t-tests between the conditions. So let's talk about ventilatory threshold really quickly here. It's a non-invasive way of determining the anaerobic threshold, and it's supposed to reflect what's happening with lactate. The drawback to doing lactate is that you have to get a blood sample after every stage. So ventilatory threshold it's a nice and it's a non-invasive way of determining where the shift occurs from aerobic metabolism to anaerobic. It does have a practical application, which I will demonstrate next. Okay, so in this example we're going to look at 2 athletes, athlete 1 in red and athlete 2 in blue. We're going to say that they both have the same VO2 max, except that athlete 1 can run at a speed, or his lactate threshold occurs at 70% of his VO2 max, which allows him to run at a speed of around, we'll say 7.7 miles an hour. Athlete 2 has a lactate threshold that's lower, 60% of his VO2 max, and because of that he can only run at 6.7 miles an hour. So it looks like there's a 1 mile an hour difference, which might not seem that bad, but if we apply it over the course of, say, a half marathon, athlete 1 will be able to run it in about 1 hour and 45 minutes, and athlete 2 will take about 2 hours to run. So athlete 1 would have been finished about 15 minutes earlier and in the tent and drinking their chocolate milk and recovering when athlete 2 is just barely rolling through the tape. So we're going to use an article by Gaskell and colleagues, and I've provided that for you on the course website. This will give a detailed explanation of the 3 methods of ventilatory threshold that we're going to use. And the 3 methods are the ventilatory equivalent method, excess carbon dioxide method, and the modified V-slope, which we will go through individually. So you're going to open up your VO2 Max Excel spreadsheet. I've provided an example for you that you'll do for homework, and then we're going to actually get in the lab and do VO2 maxes and then derive your own personal spreadsheet. Either way, you're going to open it up and then you'll find 2 columns. So this is an example of what the spreadsheet will look like. I'm sorry it's so small, but you're going to go and you're going to go to the right until you find column P, that's the ventilatory equivalent for oxygen, and then column Q, which is the ventilatory equivalent for carbon dioxide. It used to be that there were some metabolic systems that didn't do this calculation for you. You could do it fairly easily on your own. Basically what we're doing is we're taking either oxygen uptake or carbon dioxide, and we're dividing it by ventilation. Let me go back to this slide. VEQO2 stands for the ventilatory equivalent for oxygen, and VEQCO2 stands for the ventilatory equivalent for carbon dioxide. And since we've already been provided with those 2 columns, all we need to do is to create a chart that will allow us to visualize where the ventilatory threshold occurs. So you're going to open up your chart wizard, and I realize that there are a lot of different versions of Excel, so I might be going through and explaining it, and it might be totally different in yours, but hopefully it'll be good enough for you to be able to follow along and to create your own chart. So we're going to go to the chart wizard, and on here it's charts. We need to open up an XY scatter plot. And it opens up there for us. I'm going to right click and then select data. I'm going to go to add. And your instructions say that for the X values, we're going to add column A. This is our time. And in the Y value, we're going to highlight what's in column P. And I forgot, your instructions also say to do ventilatory equivalent for oxygen. Click OK, and then you've got it there. I always like to remove the lines just because it makes it look a bit better. I'm going to add another column that we're going to call ventilatory equivalent for carbon dioxide. The X value again is time, so that's in A. And then the Y value is over here in Q, so we're going to highlight that. Click OK. I'm going to extend this out and actually make this a little bit bigger so we can see. What you're supposed to see is That ventilatory equivalent for carbon dioxide not really change, which we can see there. And then we're looking for the place where ventilatory equivalent for oxygen increases kind of substantially. And this one is a little misleading perhaps, and probably something that we could do is to go over here to our axis. If I can figure out how to do this. Format the axis. Pull this down so that you can see it. We have a lot of dead space between 0 and 15. So I think what I'm going to do is to make the minimum 15, and that will allow us to take a look at this a little bit better. And the first couple of minutes are a little bit of a wash. What we should be seeing here with ventilatory equivalent for carbon dioxide is it being pretty nice and flat. So we're going to ignore kind of what's happening in those first 5 minutes. And we're going to focus in on the blue, probably starting from about here. So it's pretty level until we get to this point, and then it starts to increase. So I'm going to say that the ventilatory threshold occurs at 9 minutes and 30 seconds. So what we need to do then is we need to look at this, and actually what I'm going to also do is I'm going to insert a shape, and I'm going to insert an arrow so that I know where it is that the ventilatory threshold occurs. So now what we need to do is we need to go to 9 minutes and 30 seconds. We're going to look at our VO2 in the R column, and at 9 minutes and 30 seconds oxygen uptake was 43.4. And what we need to do is we need to express the ventilatory threshold as a percent of the VO2 max. VO2 max is the highest oxygen uptake that a person has. So it's down here at 59.7 milliliters per kilogram per minute. So then what we need to do is we need to take 43.4 and divide it by 59.7 and then multiply it by 100. That'll convert it into a percentage. And for this person, their ventilatory threshold was 72.7. And what I've done is I have inserted another shape. It's a text box. So in addition to the arrow denoting where I have chosen to do my ventilatory threshold, I'm also telling you that it occurs at 72.7% of the VO2 max. Okay, so if you are a visual learner, I've gone to the next slide. The slides are provided for you on the course website, and I've already talked through all of these. I've also talked about how to determine where the ventilatory threshold occurs, to mark it with an arrow, and then to add a text box that shows what the percentage is. So the next thing that we're going to do is we're going to talk about how to determine a ventilatory threshold using the excess carbon dioxide method. With this method, you're not so lucky. You need to create a new column in your Excel file, and we're going to call it EXCO2. And we are back here on our Excel file. I don't think it matters where you put the column, just as long as you remember where you put it. So we've made our new column right here, and we need to put in our equation. And what I would recommend you doing is opening up the Word document that I've provided for you also on the course website. That way you can open it up and you can highlight this equation. I would go ahead and copy that. And then I'd go here and paste it. And you can see that it pasted, and then it provided what the there we go. It provided what the result was. And what you need to do is you need to put that equation into all of the cells. You can either cut and paste and make sure you change the correct row number, or if you take a look at this, you find this little square at the bottom right hand corner. You click on it and drag it down, and it will do all of the calculations for you, which is pretty nice. Okay, so I'm going to go back to our PowerPoint slide, and when we enter that equation, essentially what we were doing is we were entering the equation that was found in that Gaskell article. And I talked you through this already. You highlight the cell, you drag down the small box, and it'll do all the rest of the calculations for you, which is nice. It's a nice little trick for any of the other serial calculations that you have to do. Just like we did with the just like we did with the ventilatory equivalent method, we need to create a chart using the XY scatter plot. And in our chart, we're also going to use the time in column A as our X, and then we're going to use our newly created excess carbon dioxide column as the Y. And we're going to do the same thing where we're going to mark it with an arrow and then put in the percent. Okay, so I'm going to do this for you real quick. I'm going to go to charts, I'm going to go to the scatter plot. I'm going to select my data, I'm going to add. Actually, I don't think you need to put the name in because you're only putting one quantity in. But for the A, you're putting time. Sorry, for the X value, you're putting the time in column A, and then for the Y, you're putting this newly created excess carbon dioxide value. Press OK. I'm going to get rid of this and that. Again, we're going to kind of ignore this initial part, and we're going to look for the place where it starts to increase significantly. And here, I'm going to say it occurs at minute 11. So what we need to do is we need to, let's see, insert your shape. We're going to say that it occurs right there. And then at minute 11, we determine that VO2 is 49. So I'm going to take 49, divide it by the VO2 max, which is 59.7, multiply it by 100 to convert it into a percentage. And in this case, the VO2 max, or the, sorry, I'm trying to do two things at once. The ventilatory threshold turns out to be 82, say 0.1%. So it's a little bit different, and that's fine. It's one of the reasons why the authors of the article propose that you need to do multiple methods of determining ventilatory threshold. Okay, so I just barely took you through this on how to determine a ventilatory threshold, how to mark it with an arrow, and how to put the text box, and make sure that you put the percentage in your text box. So the last method that we're going to talk about is the modified V-slope, and this is kind of your classic method for determining ventilatory threshold. With this, we're just going to use a chart wizard. We're again going to use an XY scatter plot. We are going to use column L, which is VO2 in milliliters per minute, as your X, and column M, which is right next to it, which is VCO2, again in milliliters per minute, as our two columns. Okay, so we're going to go back here. We're going to go to charts, scatter plot. This out of the way. select our data. So for the X value, we're going to highlight everything that is in column L. And the Y value, we're going to highlight everything in column M. Click OK. Get rid of this garbage. And as we have done previously, we're going to look for the place where it starts to increase significantly. And let's see. With this, it might be nice to draw some straight lines. And I'd kind of probably ignore that part. So essentially what we're going to do is we're going to look at our chart and see where the lines intersect. So I'm going to say it occurs there at 3082 and 2736. So that's right here at 8 minutes and 30 seconds. And just like we did before, insert our arrow. We need to determine what the ventilatory threshold is. So VO2 is 40 divided by VO2 max, which is 59.7. Multiply it by 100, and that gives us a ventilatory threshold using the modified V-slope as 67%. So 67% for this method of determining ventilatory threshold. And now you know all that you need to know in order to carry out this part of the laboratory.